Hi friends, welcome to the video on methods of sampling. In this video, we are going to see the concept of population and sample, the process of sampling, the two major laws of sampling, essentials of sampling, methods of sampling, and the factors influencing the selection of sample size. Let us discuss about the concepts of population and sample. A population is the entire group that you want to draw conclusion about. A sample is the specific group that you will collect data from. A population is a complete set of people or objects with a specialized set of characteristics, and a sample is a subset of population. The size of the sample is always less than the total size of the population. For example, if we want to study the average pocket expenses of students in a city where 40,000 students are studying in the city, the statistical population is 40,000 students, and if we draw 4,000 students from the total population of 40,000 students, and this 4,000 is the sample size. Sampling is simply the process of learning about the population on the basis of a sample drawn from it. Thus, in the sampling technique, instead of every unit of the universe, only a part of the universe is studied, and the conclusions are drawn on that basis for the entire universe. A sample is a subset of population units. The process of sampling involves three elements: selecting the sample, collecting the information, and making an inference about the population. These three elements cannot generally be considered in isolation from one another. Sample selection, data collection, and estimation are all interwoven, and each has an impact on the others. Sampling is not haphazard selection, it embodies definite rules for selecting the sample. Laws of sampling. There are two important laws on which the theory of sampling is based: law of statistical regularity and law of inertia of large numbers. Let us take the first law. This law is derived from the mathematical theory of probability. This law points out that if a sample is taken at random from a population, it's likely to possess almost the same characteristics as that of the population. By random selection, we mean a selection where each and every item of the population has an equal chance of being selected in the sample. In other words, the selection must not be made by deliberate exercise of one's discretion. A sample selected in this manner would be representative of the population. If this condition is satisfied, it is possible for one to depict fairly accurately the characteristics of the population by studying only a part of it. For example, if we want to make a study of the average height of the students of university, it's not necessary to measure the heights of each and every student. A few students may be selected at random from every college, their heights measured, and the average height of university students in general may be inferred. Then coming to the next one, law of inertia of large numbers. This law is a corollary of the law of statistical regularity. It's of great significance in the theory of sampling. It states that other things being equal, larger the size of the sample, more accurate the results are likely to be. To put it in a nutshell, the law of statistical regularity emphasizes upon the random selection, and the law of inertia of large numbers focuses on the large sample size. A sample should possess the following essentials: representativeness. A sample should be so selected that it truly represents the universe, otherwise the results obtained may be misleading. To ensure representativeness, the random method of selection should be used. Adequacy. The size of the sample should be adequate, otherwise it may not represent the characteristics of the universe. Independence. All items of the sample should be selected independently of one another, and all items of the universe should have the same chance of being selected in the sample. Homogeneity. When we talk of homogeneity, we mean that there is no basic difference in the nature of units of the universe and that of the sample. If two samples from the same universe are taken, they should give more or less the same unit. With these basic concepts, let us proceed to the methods of sampling. The various methods of sampling can be grouped under two broad heads: probability sampling, also known as random sampling, and non-probability sampling, also known as non-random sampling. Probability sampling methods are those in which every item in the universe has a known chance or probability of being chosen for the sample. This implies that the selection of sample items is independent of the person making the study. Non-probability sampling methods are those which do not provide every item in the universe with a known chance of being included in the sample. The selection process is at least partially subjective. Then coming to the advantages of probability sampling. Probability sampling does not depend upon the existence of detailed information about the universe for its effectiveness, and probability sampling provides estimates which are essentially unbiased and have measurable precision. And thirdly, it is possible to evaluate the relative efficiency of various sample designs only when probability sampling is used. Then coming to the limitations of probability sampling. Despite the great advantages of probability sampling techniques, it has certain limitations, because of which non-probability sampling is quite often used in practice. These limitations are: first, probability sampling requires a very high level of skill and experience for its use. It requires a lot of time to plan and execute a probability sample. The cost involved in probability sampling are generally large as compared to non-probability sampling. Non-random sampling is a process of sample selection without the use of randomization. In other words, a non-random sample is selected on the basis other than probability consideration, such as convenience, judgment, etc. The most important difference between random and non-random sampling is that the pattern of sampling variability can be ascertained in the case of random sampling, but the same cannot be assessed in the case of non-random sampling. Let us look into the classification. Under probability sampling, we have unrestricted sampling and restricted sampling. Under unrestricted sampling, we have simple random sampling, and this simple random sampling can be done with the help of lottery method, coin tossing method, moving number wheel method, table of random numbers method. Then under the heading unrestricted probability sampling, we have systematic sampling, multistage sampling, stratified sampling, and cluster sampling. Then under the category of non-probability sampling, we have accidental sampling, convenience sampling, judgment sampling, snowball sampling, and quota sampling. For better understanding, again, the sampling methods is shown in the form of a chart. So this sampling methods, here we have two broad categories, and non-probability sampling methods and probability sampling methods. Under non-probability sampling methods, we have judgment sampling, quota sampling, convenience sampling. Under probability sampling methods, there are again two broad classifications: unrestricted random sample and restricted random sampling. Unrestricted random sampling and restricted random sampling method. Under restricted random sampling method, we have stratified sampling method, systematic sampling method, and cluster sampling method. The simple random sampling technique comes under unrestricted random samples. Let us discuss in the following slides each one of these methods in detail. Simple random sampling method. The simple random sampling refers to that sampling technique in which each and every unit of the population has an equal opportunity of being selected in the sample. In simple random sampling, which items get selected in the sample just a matter of chance. Personal bias of the investigator does not influence the selection. Random here does not mean haphazard selection. To ensure randomness of selection, we may adopt either the lottery method or consult a table of random numbers. So let us discuss the first method, the lottery method. This is a very popular method of taking a random sample. Under this method, all items of the universe are numbered or named on separate slips of paper of identical size and shape. These slips are then folded and mixed up in a container or drum. A blindfold selection is then made of the number of slips required to constitute the desired sample size. The selection of items thus depends entirely on chance. The method would be quite clear with the help of an example. If we want to take a sample of 10 persons out of a population of 100, the procedure is to write the names of the 100 persons on a separate slips of paper, fold these slips, mix them thoroughly, and then make a blindfold selection of 10 slips. This method is very popular in lottery draws, where a decision about prices is to be made. However, while adopting lottery method, it's absolutely essential to see that the slips are of identical size, shape, and color. Otherwise, there is a lot of possibility of personal prejudice and bias affecting the results. Then the next method is table of. The lottery method becomes quite cumbersome as the size of population increases. An alternative method of random selection is that of using the table of random numbers. The random numbers are generally obtained by some mechanism which, when repeated a large number of times, ensures approximately equal frequencies for the numbers from 0 to 9 and also proper frequencies for various combination of numbers. Several standard tables of random numbers are available. The popular among them are Tippett's random number tables consisting of 41,600 random numbers digits grouped into 10,400 sets of 4-digit random numbers. Fisher and Yates table of random numbers with 15,000 random digits arranged into 1,500 sets of 10-digit random numbers. Kendall and Babington Smith table of random numbers consisting of 1 lakh random digits grouped into 25,000 sets of 4-digit random numbers. Rand Corporation table of random numbers consisting of 1 lakh random digits grouped into 20,000 sets of 5-digit random numbers. This slide shows the first 40 sets of numbers from Tippett's table. This Tippett's table of random numbers is most popularly used in practice. As an illustration of the general appearance of random numbers, these numbers have been selected from a particular page. Preferably we have taken here the first 40 numbers. First 40 sets of numbers from Tippett's table have been selected and shown. This is an example of how Tippett's table of random numbers can be used. Suppose we have to select 20 items out of 6,000. The procedure is to number all the 6,000 items from 1 to 6,000. A page from Tippett's table may then be consulted and the first 20 numbers up to 6,000 noted down. So in this page, we are going to select 20 items which are lower than 6,000. So let us select the items numbers. Let us consult the first row. Here 2,952 is lower than 6,000, so we have selected, and the second number is excluded because it is above 6,000. Our focus is to select 20 numbers which are lower than 6,000. Then moving along the first row, the next number of selection is 3,992. And 9,792 is ignored because it is greater than 6,000. Next number is ignored. Then 5,911 is selected because it is lower than 6,000. Then 3,170 selected. So the numbers which are selected are underlined here and shown. And in the next row, similarly, those which are lower than 6,000 are selected. 4,160, 7,545. So this illustration, the consultation of the table of random numbers from Tippett's table, it shows how to select 20 numbers out of the 6,000 numbers. You have to number from 1 to 6,000, and then you have to consult a page from the table of random numbers, and you have to start from the first number and move along, and you have to choose the numbers which best fit our consideration. Systematic sampling. A systematic sample is formed by selecting one unit at random and then selecting additional units at evenly spaced intervals until the sample has been formed. This method is popularly used in those cases where a complete list of the population from which sample is to be drawn is available. The list may be prepared in alphabetical, geographical, numerical, or some other order. The items are serially numbered. The first item is selected at random, generally by following the lottery method. Subsequent items are selected by taking every kth item from the list where k refers to the sampling interval or sampling ratio, that is, the ratio of population size to the size of sample. Systematic sampling is used when a complete list of the population is available. We arrange the items in numerical, alphabetical, geographical, or any other order. If you want to select a sample of 10 students from 100 students, under this method, kth item is picked up from the sample frame and k is the sample interval. K is equal to n divided by n. K is equal to sampling interval. N is the size of the universe and small n is the sample size. So in our example, our sample size of the universe is 100 and the sample size is 10. So sampling interval k is equal to 100 by 10. 10 is the sampling interval. Every 10th student will be taken as example. 10th, 20th, 30th, and so on. The merits of this method is that this is simple and convenient. The time and work is reduced much. If we take care, the result will be satisfactory one. It can also be used in infinite population. And the drawback of this method is that it may not represent the whole population. There is the element of personal bias of the investigator. Stratified random sampling. When the population is heterogeneous or of different segments or strata with respect to the variable or characteristic under study, then it is stratified. First, the population is divided into a number of subgroups or strata. Each stratum is homogeneous. A sample is drawn from each stratum at random. The procedure involved in stratified random sampling is dividing the universe into different groups or stratas which are mutually exclusive and include all the items in the universe. Then a simple random sample is chosen independently from each group. This sampling procedure differs from simple random sampling in that the sample items are chosen at random from the entire universe. In stratified random sampling, the sampling is designed so that a designated number of items is chosen from each stratum. In simple random sampling, the distribution of the sample among strata is left entirely to chance. Some of the basic issues involved in stratified random sample are selection of the base of stratification, selecting the number of strata, and deciding the sample size within each strata. There are two types of stratified random sampling. They are proportional and non-proportional. In the proportional sampling, equal and proportionate representation is given to subgroups or strata. If the number of items is large in the population, the same will have a higher size and vice versa. In disproportionate or non-proportionate sample, equal representation is given to all substrata regardless of their existence in the population. The merits of the stratified sampling is that it is more representative and ensures greater accuracy. It is easy to administer as the universe is subdivided, and greater geographical concentration reduces the time and expenses. When the original population is badly skewed, this method is an appropriate one. For non-homogeneous population, it may yield more reliable results. And the drawbacks of this method is that to divide the population into homogeneous strata, it requires more money, time, and statistical experience which is a difficult task. If proper stratification is not done, the sample will have an effect of bias. If different state of population overlap, such a sample will not be a representative one. Cluster sampling or multistage sampling. It is also called as sampling stages. It refers to a sampling procedure which is carried out in several stages. The whole population is divided into sampling units, and these units are again divided into subunits. Suppose we want to take a sample of 5,000 households from the state of Tamil Nadu. At the first stage, the state may be divided into a number of districts and a few districts selected at random. At the second stage, each district may be subdivided into a number of villages and a sample of villages may be taken at random. At the third stage, a number of households may be selected from each of the villages selected at the second stage. To take another example, suppose in a particular survey, we wish to take a sample of 10,000 students from a university. We may take colleges, primary units as a first stage, then draw departments as a second stage, and choose students as the third and last stage. The merits of this multi-stage sampling is that it introduces flexibility in the sampling method. It is helpful in large-scale survey where the preparation of list is difficult, time-consuming, or expensive. It's valuable in underdeveloped countries where no detailed and accurate framework is available. The drawback of this method is that it is less accurate than other methods. Convenient sampling. A convenient sample is obtained by selecting convenient population units. The method of convenient sampling is also called the chunk. A chunk refers to that fraction of the population being investigated which is selected neither by probability nor by judgment but by convenience. A sample obtained from readily available lists such as automobile registrations, telephone directories, etc. is a convenient sample, not a random sample, even if the sample is drawn at random from the list. If a person is to submit a project report on labor management relations in textile industry, and he takes a textile mill close to his office and interviews some people over there, he is following the convenient sample method. The results obtained by following convenient sampling method can hardly be representative of the population. They are generally biased and unsatisfactory. However, convenient sampling is often used for making pilot studies. Questions may be tested and preliminary information may be obtained by the chunk before the final sampling is decided upon. Judgment sampling. In this method of sampling, the choice of sample items depends exclusively on the judgment of the investigator. In other words, the investigator exercises his judgment in the choice and includes those items in the sample which he thinks are most typical of the universe with regard to the characteristics under investigation. For example, if a sample of 20 students is to be selected from a class of 100 students for analyzing the spending habits of students, the investigator would select 20 students who, in his opinion, are representative of the class. The use of judgment sampling is justified under a variety of circumstances. When only a small number of sampling units are in the universe, simple random selection may miss the more important elements, whereas judgment selection would certainly include them in the sample. When we want to study some unknown traits of a population, some of whose characteristics are known, we may then stratify the population according to these known properties and select sampling units from each stratum on the basis of judgment. This method is used to obtain a more representative sample. And in solving everyday business problems and making public policy decisions, executives and public officials are often pressed for time and cannot wait for probability sample designs. Judgment sampling is then the only practical method to arrive at solution to their urgent problems. Judgment sampling method is, however, associated with the following limitations. Number 1, this method is not scientific because the population units to be sampled may be affected by the personal prejudice or bias of the investigator. Thus, judgment sampling involves the risk that the investigator may establish foregone conclusions by including those items in the sample which conform to his preconceived notions. And another drawback is that there is no objective way of evaluating the reliability of the sample results. The success of this method depends upon the excellence in judgment. Quota sampling. Quota sampling is a type of judgment sampling and is perhaps the most commonly used sampling technique. in non-probability category. In a quota sample, quotas are set up according to some specified characteristics such as so many in each of several income groups, so many in each age, so many with certain political or religious affiliations, and so on. Each interviewer is then told to interview a certain number of persons, which constitute his quota. Within the quota, the selection of sample item depends on personal judgment. For example, in a survey on online purchase behavior, the interviewers may be told to interview 500 people living in a certain area, and that out of every 100 persons interviewed, 60 are the housewives, 25 are business people, and 15 are children under the age of 15. Within these quotas, the interviewer is free to select the people to be interviewed. The cost per person interviewed may be relatively small for a quota sample, but there are numerous opportunities for bias which may invalidate the results. Snowball sampling. Snowball sampling or chain referral sampling is defined as a non-probability sampling technique in which the samples have traits that are rare to find. This is a sampling technique in which the existing subjects provide referrals to recruit samples required for a research study. There are certain segments of population which are hard to contact. For example, if a researcher intends to understand the difficulties faced by HIV patients, other sampling method will not be able to provide these sensitive samples. In snowball sampling, researcher can closely examine and filter members of a population infected by HIV and conduct a research by talking to them, making them understand the objective of research. This sampling technique can be used for a population where there is no easily available data like the demographic information. The snowball sampling method is extremely used where a population is unknown and rare, and it is tough to choose subjects to assemble them as samples for research. This sampling technique can go on and on, just as snowball increasing in size till the time a researcher has enough data to analyze to draw conclusive results that can help an organization make informed decisions. Among the advantages of snowball sampling, we can include the following points. It is quicker to find samples. It's cost-effective method, and it is suitable for sample hesitant subjects. And regarding the drawbacks, researcher might only be able to reach out to a small group, and lack of cooperation is an important drawback of this method. The participants may not cooperate with the researcher. To conclude, the probability random sampling is more preferable because the researcher can generate his data for the use of entire population. Moreover, by using probabilistic method, the significance of the result or the confidence of the result can be estimated. Selection of the sampling method depends upon the population to be studied, that is the nature of the population, the size and heterogeneity or homogeneous nature of the population, the resources available, and the importance of having a precise estimate of sampling error. Thank you friends, thank you for watching.